Hey Joe, we're back here. We're going to do a little bit more with the intermolecular forces. What do you think this one's going to be about?
I'm thinking this is going to be dipole-dipole.
Yeah, we're going to be doing dipole-dipole. So, might as well get started. The dipole-dipole forces, Joe, have everything to do with partial charges now, okay? And so remember, this is the fourth strongest force because hydrogen bonding is a specific type of dipole-dipole,
Okay.
right? So we're actually, we kind of, look at this as the general thing here. Okay, anyways. So what we have, remember, as with any intermolecular force, what do we have? We have an attraction between
Positive and a negative.
positives and negatives. So we have to find positives and we have to find negatives. So for this molecule, NF3, okay, we have the positive side here on the N, which is going to be attracted to the negative Fs. And so there's an attraction there between those two molecules. Or if we had a bajillion of these molecules, there's an attraction here. And then, believe it or not, Joe, we could take this and we could spin this around. The nitrogen could be attracted to this fluorine here. And so there's just an attraction that's going on between all these molecules.
Okay.
That's actually where the term intermolecular forces comes from. Between molecules, forces that exist between molecules, right? Okay. So dipole-dipole forces exist here, but we should be able to rank how strong those intermolecular forces are. And so in terms of dipole-dipole forces, what we're going to do is we're going to use this guy. And my students should all recognize this as the scale of differences in electronegativity. Okay? So the greater the difference in electronegativity that a bond has, the more polar it is,
Okay.
the more ionic character it has, sometimes we say. Okay, so much so that sometimes there's a difference in electronegativity and the bonds are not polar. There's no partial charge. But when you're between the 0.4 and the 1.7, there is a partial charge. The closer you are to 1.7, the more polar something is.
Okay.
So that means that the more polar it is, the more likely that these atoms are going to be attracted, that this positive is going to be attracted to this negative, or that this negative is going to be attracted to this positive. So the more polar the molecule is, the more likely, the stronger the intermolecular force is going to be for dipole-dipole forces. So what does this mean? The more polar the molecule is, the more likely it is that the atoms are going to be found closer together. Because
Okay.
it's the intermolecular forces that causes them to
And it's
stick
stronger.
together, and
Okay.
it becomes stronger. And so if you have stronger intermolecular forces, you're going to have higher melting points and higher boiling points.
Yeah.
So these compounds here that are polar, okay, are attracted to each other, but they're not super strongly attracted to each other. So polar compounds that exhibit dipole-dipole forces are more likely going to be liquids at room temperature
Instead of solids?
because what kind of compounds are solids?
Because solids are ion-ion.
Ion-ion, exactly right. And so in this case, dipole-dipole forces are governed by the strength or the size of the polarity. Does that make sense?
Yeah, it makes sense.
Any questions on this? You had a really good question with the ion dipole ones.
So the size of the dipole is so you're looking at the size of the dipole and you're weighting it on a scale
Sure.
to determine
scale right here.
the strength
Right.
or the like the structure or the forces
You're using that to determine the size of the dipole. Okay? You're using this scale to figure out how strong the dipole is.
Oh, okay.
Okay? The stronger the dipole, the stronger the forces.
Okay.
The more likely it is to be found as a liquid or maybe even a solid. Okay,
So it could be a solid.
could be a solid, but most likely it's going to be a liquid. Any other questions?
That's about it for this one.
Okay, well, you want to join us for another one?
I would love to.
Okay.